Hello. So, welcome. I came across this video by Paul Beckwith that I will link below, in YouTube at least. If I post this on Twitter, maybe I won't have all the details, but on YouTube, which I will link on Twitter if I do link. If I do post it on Twitter, anyway, doesn't matter. It matters, but doesn't matter. Point is, this is really fascinating. So essentially, I'll link this video. He does a really good job. I watched the whole of it, discussing all sorts of details. He goes into the articles, so we're just going to look at one of them, just get an idea. He goes into the processes involved, and then into these nodules on the Wikipedia, which we got over there, and then some other topics with regard to mining. The whole reason this happened, this peer-reviewed paper, evidence of dark oxygen production at the abyssal seafloor. When they're basically studying these nodules, so let's check out this story, because so a Washington Post story. Scientists find dark oxygen being produced from metals on the seafloor. Scientists by Annabelle Timsit. Scientists have found evidence that metals naturally occurring on the ocean floor may be able to produce oxygen. A potential game changer, they say, could change our understandings of the origins of life on Earth. The researchers whose study was published Monday in the journal Nature Geoscience found that through a newly discovered process, masses made of minerals such as manganese and iron, often used to make batteries, can produce oxygen even in complete darkness. Organisms normally need the light to produce oxygen through a process known as photosynthesis, etc., etc. The masses formed over, but researchers believe electrochemical activity produced by these masses, called polymetallic nodules, can extract oxygen from water. And the implications they talk about, very unusual finding, he says. Apparently there's an interview. Maybe I can try to find that. This article came out days ago, so I don't know if the interview... Anyway. Could have implications for the deep-sea mining industry, whose players have sought to be allowed to explore the depths of the ocean and retrieve minerals like those that make up polymetallic nodules. So they want to bring these up. Such minerals are seen as crucial for the green energy transition. So notice what's happening. Now we got this side of things, where because all we can envision as a society is what we presently know, we've decided that, well, let's go mine the ocean. Like, are we done coming up with potential solutions? Because maybe before we do all that and make the profits, which is definitely a driving force, they're like, well, it's better than if we mined over there. Well, maybe we don't need green technology, so are you sure you're not just trying to make money? Anyway, before I get into that kind of thing, environmental activists and many scientists believe deep-sea mining is dangerous because it can destabilize ecosystems in unpredictable ways and could affect the ocean's ability to help contain climate change. The study received funding from companies active in seabed mining exploration. I basically told my student, he thought his research equipment had malfunctioned when they first looked at it in 2013. Sorry, I'm just jumping ahead. Maybe I shouldn't skip paragraphs. When Andrew Sweetman, the lead author of the study, first recorded unusual oxygen readings coming from the bottom of the Pacific Ocean in 2013, he thought his research equipment had malfunctioned. I basically told my students, just put the sensors back in the box. We'll ship them back to the manufacturer and get them tested because they're just giving us gibberish. And every single time the manufacturer came back, they're working, they're calibrated. So this is anomalous. I mean, just from the standpoint of like life on Earth and how we as a society tell ourselves basically the past was, where there was this evolution of this process of plants producing oxygen, and then animals, like a sequence. And this effectively is showing the sequence doesn't have to have happened, because rocks were producing oxygen, so there didn't need to be plants producing oxygen necessarily. I mean, I don't know what these animals would be eating. I guess just one another, period, but just like fish kind of do in some ways, if they're big enough. 2021 and 22, Sweetman and his team returned to the Clarion-Clipperton zone. So here's another oddity that caught my attention. Of all places, an area under the Central Pacific, which, if you don't know where that is, we'll get back to there, so it doesn't matter right now, known for having large quantities of polymetallic nodules. So let's just look it up real quick. Not like I'm like, oh, I know where it is. I generally know. It's between Hawaii and Mexico. It's in the paper too, so it's not like I would have even necessarily known exactly. I just know that, here we go, like these things. The fracture in this zone, between these fractures, in this zone, okay. Some reason in that zone, not everywhere, but certainly in a lot of places, but especially in that zone, known for having large quantities of polymetallic nodules. Confident that their sensors worked, they lowered a device more than 13,000 feet below the surface that placed small boxes into the sediment. Boxes stayed in place for 47 hours, conducting experiments and measuring levels of oxygen consumed by the microorganisms that live there. Instead of oxygen levels going down, they went up, suggesting that more oxygen was being produced than consumed. The researchers hypothesized that the electrochemical activity of the different metals that make up polymetallic nodules were responsible for the oxygen production measured by the sensors, like a battery in which electrons flow from one electrode to another, creating an electric current, said Tobias Hahn, one of the co-authors of the study, in an interview. This hypothesis would add a layer to our understanding of how organisms came to exist under the sea, said Hahn, who focused specifically on the sensors used in the study experiments. We thought that life began on Earth when photosynthesis kicked in, as oxygen was brought to Earth through photosynthesis. It could be that actually this process of electrochemically dividing water into oxygen and hydrogen supplied oxygen to the ocean. This could be a kind of game. Mind you, this is all in the modern paradigm. It's not necessarily as as significant in like the interpretation that I put forth, because I basically said 500 million years, 541 to the Holocene is the global flood when the Earth expanded. So it's a totally different paradigm. So the angle they're looking at it is like, oh well, life coming from this like is a possibility. Like that there's oxygen from plants and from this now. So it could have arisen without the plants. So now we've got this like really significant thing. But to me, since it's all during the flood, these nodules, it's not like that this was like the life-giving thing. It was just a part of the process of what was happening. It just happens to produce oxygen in this way, and maybe in cool ways, because it's like got characteristics that are like, okay, something's up here. Something's up with these things that huh. Let's keep going. A news release about the study said its findings challenged long-held assumptions that only photosynthetic organisms such as plants and algae generate Earth's oxygen. But if that finding is borne out, we need to rethink how to mine materials like cobalt, nickel, copper, lithium, and manganese underwater so that we do not deplete the oxygen source for deep sea life. Fascinating. It's just fascinating, just period. Just thinking about it. But said Franz Geiger, a professor of chemistry at Northwestern University and one of the co-authors of the study in the release. It's funny I talk so much shit on archaeologists lately. I feel a little bad. They are certainly scientists. I apologize. It's just they're unfortunately not trained in areas that really are going to matter soon. But they have training in other areas that will matter soon too, so it's okay. It's just like we gotta figure out what's true and not just what someone told us to be true, which is basically what happens when we're a scientist who's relying on another scientist. Like, we fully trust that they are doing everything correctly and have not made a false interpretation at any point, have not, like, accepted someone else's false interpretation. They don't even need to. They can just accept someone else's, do everything perfectly correct, but accept one mistake that is pivotal enough to change the totality of what they're doing, be utterly perfect in the scientific method, and still not arrive at the correct answer because of this underlying thing. And to rely on someone fully, just, I trust you. I trust you. You've got the paper. Got the societal approval. So I fully trust you. That is not science, guys. That's not how science works. Science is not faith-based. I have faith in you is another way to say I trust you. I have faith in you. I see you. I have faith in you. Wait, you were wrong? Ah, shit. That's religion now. That's the problem. Anyway, let me not go ranting about other things. I'm just like, clearly I'm rude. Mining conducted under the sea in the 1980s serves as a cautionary tale, Geiger said. When marine biologists visited such sites decades later, they found not even bacteria had recovered. I don't even think I noticed him reading that in the first time I watched the video. I was like half paying attention, honestly. It's more focused on the geological characteristics of what the hell's going on here, and maybe the chemistry, like fractally, like something's going on fractal for sure. Why such dead zones persist for decades is still unknown. But the fact that they do suggests that mining the seafloor in areas with plenty of polymetallic nodules could be especially harmful because those areas tend to have more faunal diversity than the most diverse tropical rainforests. So these nodules are in areas that are that diverse, like sea life wise, more more diversity than the most diverse tropical rainforests because of these nodules. I mean, this is in darkness. There's no sunlight, deep ocean waters. And these creatures are living off of oxygen that literally does not permeate down to the depths. And yet it's there because it's apparently being generated by these things. Though the study has pointed to an interesting new pathway for sustaining life. Okay, this doesn't. Here we report such a deep sea flora organisms consume oxygen, which can be measured by in situ benthic chamber experiments. Here we report such experiments at the polymetallic nodule-covered abyssal seafloor in the Pacific Ocean, in which oxygen increased over 2 days to more than 3 times the background concentration, which from ex situ incubations we attribute to the polymetallic nodules. Given high voltage potentials up to 0.95 volts on nodule surfaces, we hypothesize that seawater electrolysis may contribute to this dark oxygen production. And then, let's see, polymetallic. I'd like to see it. Here we go. We undertook multiple in situ benthic chamber lander experiments to measure abyssal sediment community O2 oxygen consumption. Where were we? To measure abyssal sediment, so basically the oxygen consumption by things in the sediment, I guess. Okay. In the Nauru Ocean Resources Inc. license area of the Clarion-Clipperton zone, where polymetallic nodules cover extensive areas of seafloor. Sediments and nodules were exposed to different experimental treatments, which included the addition of dead algal biomass, dissolved inorganic carbon, and ammonium or cold filtered surface seawater. No injection controls, I guess, control experiments where no injections were performed. No injection controls were also performed. In contrast to previous deep sea oxygen flux studies that only showed sediment community oxygen consumption, we consistently found that more oxygen was accumulating in the chambers than was being consumed, resulting in net oxygen production. Constant linear decreases in O2 optod readings were observed in 2 experiments. Figure 1. Okay, let's see. Oxygen concentrations measured by calibrated O2 sensors through time in H incubation time in the different benthic chamber incubations. I guess hours, probably, each. A to C, the in situ benthic chamber, let's see. Lander deployments were made during the 5D, 5E, and 7A cruises. So some cruises, nodules were present in all incubation experiments. The green hue, blue hue, and red lines in the 5D figure A denote dead algal biomass. Green hue. Dissolved inorganic carbon and filtered seawater treatments, respectively. The gap in the optod data was caused by the optod periodically not logging. It's up there, I guess. A black line indicates ambient O2 concentration measured on the outside of the benthic chambers. Black line. Okay, we're... That's pretty conclusive looking. About 180, like with no chamber. This is the equilibrium of the environment with the like amount of oxygen production as a result of these nodules, I guess, and like the loss from just like saturating into regions with less oxygen that then like stabilizes as a balance point around like 180, it seems, in that location, and then across hours it goes up in this case to 500, so almost 3 times, and definitely a substantial enough amount it goes up in these that if there's no oxygen source, I mean, I assume there's no oxygen source other than the nodules. Like that, nothing that can be, like there's no plant life because there's no sun. So I assume it is their interpretation. I don't know how conclusively they've managed to prove there's no other source possible. I mean, it seems like they did the experiment, though, on the nodules themselves, like, purposely to a point where they're like, okay, it's the nodules doing it. So it seems to be these nodules doing it. So let's move on from this. Nodules, long story short, are having some effect on the water and turning it into oxygen. Map globe. Let's see. I was trying to find these kinds of things. I'm like, okay, where are they? Let's see where they are, because clearly, I mean, they're in the Clarion-Clipperton zone. So, before we look at this, places I commonly reference. Right here specifically. Right here specifically. I'm like, oh no, now I'm forgetting where they're at. This is in my recent video. We're coming to look at this area for when Hawaii coming back this way, the sphere, as the expansion process was happening. Theoretically, we were talking about this area, and off the side here, I believe it's between this one actually and this one. Maybe related to over here, like this opening, some kind of decay product. Because if we look at the map, like, they are concentrated over there. They're concentrated not quite where I would expect them. Like down here, they're really over by Cook Island in this area. So here's New Zealand, here's Fiji, right there. So I'd really expect them more maybe around it, but it's possible they got shoved to one side where they're all generally over here for some reason, if they're related to this general process and related to this position in some way. And then this position, it's generally here. I was thinking maybe when all of this was happening, the North America and South America were being divided apart, and the Caribbean was opening. So there's a current going through the Caribbean region from the Pacific. So maybe it deposited some of these nodules over here, and then they made their way over down in this area, got like caught in this area and over there, just kind of deposited there. That went through here though, from over here, and went over this way and generally down, but some like all the way across. Some got across, some got up and into this area where there's an eddy that was happening here. So I was able to get some in there, but then it generally went around this way, maybe. Ooh, it makes me think there might have been a current at some point that was more going around. But then depositing as it goes between South America and Africa, leaving some of these deposits. But from a process over here is what I'm getting at, is just some thoughts. And then also like down through this way and around here to then go generally up to like where it meets resistance. Pretty much this current going through that way doesn't really meet resistance until it gets to around here. So it looks like maybe it deposited some over there. None that are referenced in the Arctic. Maybe we haven't found them, but I would imagine we would have seen some evidence of them where someone, like a map like this, would show them if they were that prevalent there. So they might be there, just not very prevalently, which would kind of point to like, how did it get there from over here? It's not quite as easy to get there. It would have to go up that way or through here. So it's kind of disconnected from some explosive energy that's over here that goes out that way and around this way and around this way and around to over here, down, generally away from the Arctic. So let's keep looking at some details. Largest of the, okay. I feel like we went ahead. What was I reading? I don't know if I read any of this yet in this video. But what I remember being, I guess we can kind of glance at it. Polymetallic nodules are mineral concretions on the sea bottom, so they're found on the sea bottom, formed of concentric layers of iron and manganese hydroxides around a core. As nodules can be found in vast quantities and contain valuable metals, deposits have been identified as a potential economic interest. Depending on their composition and autorial choice, they may also be called ferromanganese nodules. Mineral concretions composed of silicates and insoluble iron and manganese oxides that form on the ocean seafloor and terrestrial soils. So I guess ferromanganese nodules can be more inclined to be terrestrial things, probably. Like, I imagine Moki marbles are ferromanganese nodules. Moki marbles. I don't know if they're manganese. They're definitely iron. Whoa. Square. Okay. Formation mechanism involves a series of redox oscillations driven by both abiotic and biotic processes, which is without oxygen, I believe. Or without life, sorry. And then life. As a byproduct of pedogenesis. Soil formation. The specific composition of a ferromanganese nodule depends on the composition of the surrounding soil. The formation mechanisms and compositions of the nodules allow for coupling. I mean, mind you, this. Think of shallograms as we read this. The specific composition of a shallogram depends on the composition of the surrounding soil when it was being shaped. The formation mechanism and composition of the nodules allow for couplings with biogeochemical cycles beyond iron and manganese. The high relative abundance of nickel, copper, manganese, and other rare metals in nodules has increased interest in their use as a mining resource. Nodules vary in size from tiny particles visible only under a microscope to something 8 inches, 20 centimeters, typically 1 to 4 inches, 3 to 10 centimeters in diameter. Surface textures vary from smooth to rough, frequently have botryoidal texture, so I guess like this bumpy, some like blocky, segmented, chambered. Looks kind of like a molecule. Vary from spherical in shape to typically oblate, sometimes prolate. So, oblate, prolate. Oblate. Bottom. Prolate. Top. Sometimes like that. Usually like that. Very much the same is my point. Just like shallograms. Typically oblate, sometimes prolate, or otherwise irregular. Like shallograms, like, say this one is kind of just neither. But typically, suggestive there's similarities, some kind of current process. Let's keep going because, okay, estimated 500 billion tons found in both shallow Baltic Sea and deeper waters. Baltic Sea. It's probably not specifically related to Hawaii then. Although it may be the current went up there. If it went up this way and went this way, up this way, some of it maybe could have gone in across here. Found its way over there. I don't know. I feel like there'd be a trail though. Although it might have kind of carried it, and like there, if it went through here, there'd probably be some deposits around here too, and even atop it. So that probably means that they formed more locally as a process that repeats, probably related to the eddies generally in Hawaii. The region of the Pacific having so many because of just it. That's where the energies were concentrated during the Earth's expansion process. So it just tends to make them. They're also relatively spherical, like Moki marbles or Rocky boulders. Hey man, gotta do what you gotta do. You gotta do what you gotta do. So, what else we got? I am not done for sure. Let's keep going. So generally, though, composition vary. Sizable deposits found in these places. Clipperton, Clarion Zone. Roughly midway between Hawaii and Clipperton Islands. Peru Basin in the Southeast Pacific. Indian Ocean, so these are just places we're looking at. Largest of these deposits in terms of nodule abundance and metal concentration occur in the Clarion-Clipperton zone, which kind of gives credence to some relationship to the things going on in the Pacific in terms of the Earth's expansion process. And like directing currents at specific locations that are then depositing, especially these, they're probably related even to like the eroding over here, maybe something, and the opening of the breaking of the bond, maybe there it's related to breaking of the bond, where it like decays into like electrons practically that then deposit them all over here. Some kind of fractal thing that can be seen as electrons in a like reactive kind of way. So there's about 21 billion tons estimated in that locations. But let's see if we can find. I feel like this stone is. Sorry, there was something I was reading. I don't want to jump too far. I'm just scrolling through it all. Something I was reading that probably, I'm not even sure if it's here. Million, let's just say million. Okay, there it is. Nodule growth is one of the slowest of all known geological phenomena, on the order of a centimeter over several million years. So there's no way these are forming like modern times, really. Maybe they're getting like some kind of the process happening subtly, adding particles, but like they're really not growing. They were more so millions of years were while the flood was happening, the energetic currents were high enough to actually make these things in like rapidly and in large quantity. So there's that going on. Several processes are hypothesized to be involved in the formation of nodules, including the precipitation of metals from seawater, shallograms, the remobilization of manganese in the water column. Sounds kind of like the shallogram stuff. Derivation of metals from hot springs associated with volcanic activity. So definitely associated with energetic earth processes, like really present while the earth was expanding though, and not now is the key. Sure, things are happening now, but not like then, and maybe some other day they will be like then, but it's not like then now. The derivation of metals from the hot springs associated with volcanic activity, the decomposition of basaltic debris by seawater, and the precipitation of metal hydroxides through the activity of microorganisms. Basaltic debris decomposition and the precipitation, I guess, on the decomposed basaltic debris of metal hydroxides through the activity of microorganisms on the basaltic debris, I guess. The absorption of divalent cations, such as those ones, manganese, iron, cobalt, nickel, copper, at the surface of manganese iron oxyhydroxides, known to be strong sorbents, also plays a main role in the accumulation of these transition metals in the manganese nodules. These processes, precipitation, sorption, which is absorption in a like more general form, maybe physical and chemical process by which one substance becomes attached to another. Okay, attached, so not necessarily embedded within, which would probably be more of an absorption, to actually penetrate into the space of the system, whereas sorption seems more on the surface, like a different system. It's not. Okay. May operate concurrently, or they may follow one another during the formation of a nodule. Manganese nodules are essentially so, by the way, some of it may happen then, some may happen then, some may happen then, maybe together, whatever, who cares? As long as it all happens over time, voila. I mean, there's probably some evidence. I assume, I mean, I know we're reading Wikipedia, but I assume this has some reason they would, like, believe there to be each of these things going on, and they may happen separately. Anyway, manganese nodules are essentially composed of hydrated phyllomanganates. These are layered manganese oxide minerals with interlayers containing water molecules in variable quantities. Manganese nodules are essentially composed of something of this nature. Okay, just essentially some kind of crystal lattice. I don't know if that's what this would be called, some bonding arrangement of the atoms that is what these manganese nodules are essentially arrange the atoms within themselves by that structure. These are layered manganese oxide minerals with interlayers containing water molecules in variable quantities. So remember, fractal atom. If we go over here, go to the periodic table of currents, just go to helium or hydrogen, where generally there is a container in which a current flows that can build mounds. But then over time leads to a pattern that leads to basically an ammonite structure in the pattern. Like this spirals around in an ammonite structure that then gets bigger and bigger, but it has like a certain way of its being that is following a general pattern. And the protons, though, are eddies that basically are occupying the space with a current flow that's flowing in an eddy. And then the neutrons don't have that like missing material, but then all of it is contained within a larger mass that then makes it kind of where protons and neutrons are much more similar, and that space that's missing, that's filled with a current, is like the electron. That is like the difference in the mass between a proton and a neutron. And then we see this clearly fractal thing that's got all sorts of fractal behaviors of interest that I've not seen in other places. Also has this like internal containing water aspect, like in a subtle way, so it's really down in the layers, so it could be behaving like a lot more than just like a single atom or anything, but also that probably. They strongly interact with trace metals because of the octahedral vacancies present in their layers. The particular properties of phylomanganates explain the role they play in many geochemical concentration processes. They incorporate traces of transition metals, mainly via cation exchange, in their interlayer, like clay minerals, and surface complexation by formation of inner sphere complexes at the oxide surface, as it is also the case with hydrous ferric oxides. Inner sphere complexes? Surface complex that refers to the surface chemistry changing a water surface interface to one without water molecules, bridging a ligand to the metal ion. Formation of inner sphere complexes occurs when ions bind directly to the surface with no intervening water molecules. These types of surface complexes are restricted to ions that have a high affinity for surface sites and include specifically absorbed ions that can bind to the surface through covalent bonding. This sounds very relevant to just the process of like how some like a container would form in which a current flows, that like it's forming a shell by some mechanism, like tending towards things chemically as well that are not just like pressure related out, like doing it across different dimensions pretty much. Describe active surface sites that are involved in nucleation, crystal growth, redox processes, soil chemistry, alongside other reactions taking place between a cation and a surface. This affinity to surface sites can be attributed to covalent bonding. One method to achieve inner surface or inner sphere complexes is through wetting, a phenomenon where one fluid known as a wetting agent replaces another medium like water or air on a surface. In the case of solid water to a solid liquid interface, the liquid spreads to increase the solid liquid and liquid gas interfacial area and decreases the solid gas interface and solid water area as a result. Okay, whatever. I'm just... Mineral composition of manganese-bearing minerals. Okay. How long is this? Okay, 52 minutes. I was pretty much just kind of sharing this, but let's keep going on this. Now that I remember, we're looking at millions of years. I guess millions of years, millions. So let's just say, like, when did polymetallic nodules form? Let's see what AI says. Isn't that odd that it says during the Earth's expansion process? And then it says, when the deep oceans became oxygenated. You know, like a vortex that reached down under and brought energy from space down through the Earth. Do you think that would have some deep water oxygenating capacity? Probably. Some nodules estimated to be 2 to 3 million years old. So basically, there's probably not many, if any, that have been dated to like the last anything younger than this. Like this is probably the range 540 to 2 to 3 million, like generally speaking, maybe 1 million, but I'm sure they generally stop. Not that dating at that point is even really reliable, because like Mount St. Helens has been dated to be over 1 million years old in its known eruption of whenever it was flows, so clearly the method is not that reliable to near times. So that's pretty much like practically present, practically. Given that the Earth expanded from 541 to the Holocene in the global flood, that was a span of months. It's pretty much present, leading into discovered in the Kara Sea. Okay, so they are in the Arctic, even discovered in the Arctic, so maybe they're just everywhere in the oceans. Let's go to Scholar. Polymetallic nodules. Formation, sure, I don't know. Composition, formation, occurrence, sure. That doesn't seem to want to do anything. Oh well. No one like. Let's see, just generic there. Maybe this one will have a intro section. Composed blah blah blah, very blah blah blah. Pretty much what we were just reading. From ocean water and or sediment pore waters. I don't know if that's pore, like P-O-O-R. As a result, the enormous, or just pore, like an opening? As a result, the enormous quantities of the nodules. Okay, first discovered. Number of nodules, okay. Does anyone even care about the nodules? Like, yeah, the nodules themselves. This is why people care. Not intellectually so much, it seems. Nevertheless, scientific interest in polymetallic nodules continued. Geological, oceanographic, environmental, and geochemical baseline studies were undertaken. Deep Ocean Mining Environmental Study Program, for example, involved 12 national oceanic and atmospheric administration research cruises, during 1975 to 76, which integrated data from multiple disciplines to understand the distribution, formation, and evolution of polymetallic nodules in 3 specific areas representative of the vast Clarion-Clipperton zone. The Deep Ocean Mining Environmental Study, blah, blah, blah. Okay, no one is actually going to say when they just formed. Like, are they dating them? Like, like there must be dated. I don't know, would there be zircons in there? Are there zircons found in those? Chemostratigraphic. That looks like a big ass paper. Oh my god. Maybe it's just a website. Because, scroll down. What in the fuck, dude? Detailed mineralogical and microgeochemical characteristics of polymetallic nodules collected from this area were described in the study. Obtained data were applied for the delimitation of nodule growth generations, estimation of the growth ratios. Applied methods include bulk X-ray powder diffraction. Okay. Introduction. Nothing about how old they really are. Here's some stuff. Here we go. Applied method indicated the nodule's age is mainly middle Pliocene to middle Pleistocene. So these are way recent. Which also sounds kind of related to Hawaii. Like the final portion of its decay process. Growth ratios. Additionally, few nodules showed suboxic conditions of nucleation. The growth process in the eastern part of the Clarion-Clipperton fracture zone deposit might have been induced with Plio-Pleistocene changes in the Paleoceanographic conditions related to the deglaciation of the northern hemisphere. Growth processes in the eastern part of the Clipperton-Clarion fracture zone deposit might have been induced with changes related to the deglaciation of the northern hemisphere. So they're relating these things to deglaciation process. This kind of makes sense. That's when all the things are draining into the ocean bed and interacting, and high velocity currents are maybe compacting particles together where they're more likely to actually have absorption and absorption and adsorption and combine basically into larger things that become these nodules. Nodules are fragile and often fractured. It's almost like they're saying fractal. Almost. Like fragile, fractured, oh. Fractured. I mean fractal and fractured. Maybe. With varying morphology and nuclei. Nodules are usually completely or partly buried in the semi-liquid, geochemically active layer of surface sediments. Semi-liquid. So it's fluid. Buried in it and is like part of it, almost like it's the nucleus of the cosmic system of the sediment around it that's in flux. That's literally makes it tend to be in the sediment and not just on the sediment. Maybe. to a point where it would have to be like mined. Can't just be like dredged. I don't know if that's is that the right word? Dredge. Dredging. Dredge the ocean, let's say. Maybe it could be. I don't know. Something of that nature, but not the methods that there's a crane or anything, but where was that paper? That one? Yep. Polymetallic nodules are composed of a nucleus that is surrounded by concentric ore-bearing microlayers of iron oxyhydroxides and manganese oxyhydroxide laminae, forming cauliflower-like coliforms and non-ore-bearing, irregular-shaped admixtures of detrital materials of various origins. So there's detrital material, so there's erosion by currents that are shaping detrital cauliflower-like shapes. The nodule nuclei can be clayey, zeolitic, consolidated sediment, bioclastic material, a piece of fish bone or tooth, so it has some kind of nucleating site, volcanoclastic materials or fragments of older nodules. Microlayers are highly enriched in a variety of elements relative to their average abundances in the Earth's crust and seawater. Compared to the crustal abundances, the concentration of manganese, cobalt, molybdenum, and thorium are 100 times higher, whereas those of nickel, silver, iridium, and palladium. It's been a while. Are 50 times higher, and those of copper, zinc, whatever those are, tungsten, bismuth, are 10 to 50 times higher. These high concentrations of metal, so basically these metals are much higher than like typically founded compared to the crustal abundances. These high concentrations of metals indicate that polymetallic nodules may be a prospective resource. However, currently no exploitation is being conducted. The main processes responsible for laminae formation include the hydrogenic precipitation of manganese and iron oxyhydroxides. Okay. So I think we've covered this pretty good. Could certainly keep going, but that's probably getting kind of tedious and boring, I imagine. Especially, I'm just literally reading it. Here we go, some images. This guy was scrolling down for. Little nodule type, so it's kind of maybe taking many of them and putting them together, even. I don't know. Don't know at all, really. This one seems to have like a central circle right there. And even ammonite-esque things around it. Huh. Whoa. Currents. Currents, currents, currents. Look at the currents doing all these things. Wow, that's incredible. Just looks really high energy. Oh, Lord. Whoa. What is this? Biomorphic remnants discovered in the analyzed polymetallic nodules. Porous relics of diatoms and radiolarians surrounded with massive manganese-rich oxyhydroxides. A pseudomorph of symmetric radiolarian filled with pure manganese-rich oxyhydroxides, and a remnant of cylindrical diatom composed of pure manganese-rich oxyhydroxides, developed as fine needles and surrounded by other pseudomorphs and debris material, etc. You can read the rest. I'll just go up now. Wow. So cool. It almost looks like a battery. Oh my god. Apparently this is what? Remnant of cylindrical diatom surrounded by other pseudomorphs and cylindrical diatom. Looks like a freaking battery. The fact that these things are being termed batteries and it's got something that looks like a battery in it? What the fuck? It's even got like maybe an anode cathode separator kind of thing in there. I don't know, maybe. Some kind of outflow dude, like a terminal connections. Not saying it's actually doing anything of that nature precisely, but it really well, it looks so much like it that it makes me want to think about it more. This one looks more shallogram opening, like peanut shaped. More just generally having like that kind of shape. With a center area that's just less the dark shade, like it's just less. It does seem to go in a little bit, but more so it's just less. That's got hologram features. Just the way it's like an E. I don't know what we're looking at, I'm just observing. X-ray of massive botryoidal textures observed in the polymetallic nodules. Some plot of all the composition. Other stuff. Age. Definitely finding lower ages than the 540 to Holocene kind of time frame. They're layered. They're really just growing. Wow. These things could have really cool evidence in them. I imagine not many have been looked at that closely if they're not even mining them yet. Like, they've probably mostly just been gathered and studied, and like there's a lot of shalograms and they're all different. I'm not sure. I wonder how much they've been looked at, these. Let's see if we can find a polymetallic nodule on Etsy. Prophecy stone. It's got that botryoidal. Botryoidal? I don't know. Cluster of grapes. Okay. Think I'm just gonna stop here. I don't think there's really anything else to add. Looks like I got some, probably some, love, I'm sure. I'm sure it's love. Thanks. Thanks, flipping love. See y'all later. Peace.